All right, today we're going to start. Let's share this thing. Okay, I left off at this part of hydrogenation reaction or reduction reaction. Remember, the marking scheme, they don't call it addition reaction, but hydrogenation or reduction. I mentioned to you that here the question is very specific. They actually tell you, let me give you this color first, that this part here, see now, okay, during the reaction, the hydrogen atoms, all the atoms added onto the same side of the benzene ring. That means here, now if you put these two, right, these two hydrogen molecules coming here, it will be attacking on the flat surface here. That means on the this side. That means it will enter to give you this one here. See, right? That means on here and here, on top here. Okay, or you can right at the bottom also can. All right, if you put at the bottom, it'll be like this. Okay, here, go out here, and the hydrogen, the OH should be here, and the H be here, and the H be here, and the H be here. So these two are the added ones. Okay, either way you get the mark. All right, so it says here, you can see here, here. So, how here complete the following part structure to show the structure of one of the isomers that would be formed during the above reaction. So remember these two, this one here and this one here means on the same side. That means if you put hydrogen here and here, okay, right? So it'll be an OH here and a H down here. Or it can be reversed. Now look at the marking scheme, okay? The marking scheme, 15, will be this one here. You can see, right now. Okay, can you see down here? Okay, you need to see here. Here, I need to add, okay, right, on, see, bottom, okay, or top. Okay, so that is important. So the marking scheme have two hydrogens have to be on the same side of the ring. For the LQ group, you can put the whole thing. I think it's safer to put the whole thing, right? The whole thing, or you can write it in this is the molecular form, okay? Or R also can, because there's only one R here, right? Okay, right? So this is how the marking scheme is. I want to just go over something here. You see, wait, okay. Now, just to be, well, to go a bit more. Now, this fellow here, they ask you here, you see here, right? How many part 3 here? You cannot see my cursor, it's interesting. I thought, you know, maybe I put it here, can see. Now, the here says how many possible optical isomers are there in the same structure as B, right? Now remember the number of isomers for a optical or cis trans has the formula what? Remember not? 2n, is it not? Okay, right? This is for optical as well as cis trans. So here we have 2. The carbon here and the carbon here being optically active. You put half here. No. Okay. No, sorry. Oh, I'm sorry. Here. See, I can make a mistake. So can you. Okay. Here. The carbon here and the carbon here. Right. You put halfway through here. So this is 1 group, 2 group, 3 groups. This whole thing here. And here 4 groups here. So similar with this one again. Okay, there's a H here, there's a C3H7 here, there's a halfway through here. So there are these 2. Now if you want to draw, so if they ask you, came up 1 year, draw the optical isomers, right? So there are 4. So how do you draw them? Now this one is one of them. If I put the H here, let me see, I can do it here now, okay? It's easier here. Now, doesn't matter. Okay, I do it here. Now, if we say this is the one here, because now there are actually two cis isomers. Two cis isomers, because this one here, see, if you talk about, I better do it here, okay, so it's easier for you. Now here, see now, all right, two here. So if this is the one here, so I better put the red color better. All right, so this is one. The opposite one should be what? If you ask you to draw, okay, draw like that, okay, right? Now here, same, okay, H down here like that, and your R group here, all right? Up here, right? Go like that. Up here is your hydrogen, and down here is your OH. See now, so this is your positive and this is a negative. Okay, now these two are optical isomers. So you have one optical isomers, two optical isomers there. Now what is the other one? Got four, isn't it? So the other one would be, if I can draw it here, it'd be easy for me, okay? Right? Now the other one, of course, is the cis and trans. Okay, right? Now that means if here is H, it means that now this one will not be the answer for this question. Why? Because it's not on the same side. So here would be what? OH, you know, okay? So down here would be what? H. And down here should be what? Should be a CH. Okay? So this is a possibility. But this is not what is wanted here because this is not formed. See, this is a possibility. So you got two, right? So this is your, if you say about geometrical isomers, right? Cis trans isomers is your same side is a cis. It's your trans. See now. And therefore the other optical isomers, which we have four now, okay, will be this one here. This is additional understanding, right? So here, up here, is your hydrogen. Down here will be your CH3, is 2, 2 and a CH. And here, up here be what? OH. And down here should what? H now. So this is a positive, this is a negative. That's why there are four. 1, 2, 3, and 4. 4 optical isomers. See now, but there are only two cis and trans. Cis and trans. Okay? Because of the of the arrangement, that's all. Because all the others here is H and H now. Okay? So you cannot have. So there's only one there's no double bond here. Why is this cis trans isomers? Because the ring hinders what? Hinders rotation, isn't it? Why there's cis trans isomers? Why? Again, why? Okay, because the ring, right? This ring here, hinders rotation. And why is there optical isomers? Why? Well, because of there are two chiral carbons. Okay, this is the reasons. Okay, if you want to know the reasons, this is the reasons. Okay, okay. So you can see the whole picture here. All right. So you can see. All right. Again. So I give you the whole picture now for this hydrogenation. They will ask you here. Then remember, they will also ask you about the what? About AS. So you must remember. I made a mistake that day, yesterday rather, when I did on this question here. Look at the question first, okay? I forgot to put a carbon there. If some of you are very quick, you probably can know that, okay? 408. Okay, you can see here. My mistake was what? Remember, now they are here. If you look at it carefully here, okay, there's one carbon here, 3 and 4. This one only got 3. Okay, so this is wrong here. Okay, I'm going to rub it off here. Okay, I'll rub off this one here. All right, so rub off this one here. Okay. Okay, so I redeem myself. Okay, now here should be a what? Here should be a carbon. Don't know why it's not working. Sorry, this one. The other one is not working. Carbon. Okay, here's a carbon. Okay, which is carbon here. Right now. Okay, there should be a H here, a H here, and there should be a Cl here. Yes? Okay, now let's complete this one here. Now mine are different color. Okay, so carbon, here we should be what? 3 here, 4, yeah? So we have H here, and a positive sign here. Yes, now. Right, so it's not a that here. Yes? So here also wrong. Okay, here also wrong. I rub it off first. Here also wrong. Okay, let's do it properly. Okay. Here should be a C, H, and a H. And then go to here. That's not. Okay, so this one I made a mistake here. All right. Now I finished this part already. Now I want to show you what we are going to do today. Cover new grounds. So you should know about alkylation and acylation for Friedel-Crafts reaction for electrophilic substitution. The more you do these questions here, the more you will grasp the concept and how to answer the questions. Now let's look at the syllabus for a while. Now look here, right? I finish off this. Let me just put here so I can. Here we have finished this one here. The reactions, electrophilic substitution of benzene with chlorine and bromine. But see, I want to talk about today is this one here, the methylbenzene. Okay, but before that, I'll show you what we have done. Nitration we have finished, Friedel-Crafts finished. Okay, we have finished hydrogenation. So now we're going to do this part here. But to do this part here, I must do methylbenzene. Okay. Now I also have finished the mechanism. Finished already, right? Finished already. Now, of course, here also finished. Okay. Now, these two, we are going to, all this here, we're going to do today. Okay. Here, right? We're going to do today. And of course, this one here. Hopefully, we have time to finish all this. It's quite a together sort of deal. Okay. Now, I'm going to first of all do with methylbenzene. Excuse me. Here is a methylbenzene. Okay. All right, and how is methylbenzene formed? How is it produced? And of course, in most books they have first of all preparation and then reaction. Right? So now methylbenzene. Okay, let's go to methylbenzene now here. All right, just a bit more. Something got it's hanging. I don't know why. Okay, oh, phenol. Too far. Okay, here we are. All right. Now, methylbenzene. The other notes here you can read over, okay? For this question, it's quite good for you to think about. Okay. A methylbenzene, very easy. Remember here, I want to put the cursor here. Now here, remember, methylbenzene, this is benzene. How you prepare it? Of course, alkylation. Friedel-Crafts, okay? So this is your source of the CH3 here. Okay? So this one here will remove the chlorine, okay, to give you a CH3 one. Positive, okay, we'll attack here, the kind of thing. So very simple. Now the other one, of course, is here. This is actually chemical isomerization or chemical reduction or oxidation. This is your normal heptate, okay, normal N, okay, heptane, HEPTANE, that means a straight chain, no branching. This is done, of course, in the petroleum industry. They call it reforming, or they call it isomerization. Now this one here is done in cracking, okay? This is cracking. So in a petrol, now this is present in your present petrol. This is a very lousy petrol you've done before, okay? We done AS, it's a very lousy petrol. This is a zero octane number, okay? It's one of the worst petrol because it burns very fast and burns very fast and it causes knocking. Here is the current ISO, I forgot what okay, they call it 95, raw 95, 197, okay? They use on here, okay? Right, and this is your methylbenzene, okay? So basically, there are two ways here to prepare your methylbenzene, okay? Now here, right? Here we have your orientation factors. Now this one here, well, I think I'll go over later, okay? Now reaction of methylbenzene, very simple physical properties. They are liquid, that's why you can use petrol, but of course they have a boiling point very low, okay? Right? Benzene is lower. So benzene is higher, sorry. Okay? So that's why you can use this petrol. Now there are two reactions here. The ring reactions is here, right? Now this is called the ring or the nucleus. Okay, ring. And this is called a side chain. Right? Remember? Side chain and the ring. Two reactions. The side chain will here behave. This one is carbon here is sp3. So it is just like your alkanes. So you react just like alkanes, which means that it will undergo what? Free radical. Radical what? Substitution. Substitution. The main one, of course, is with Cl2 or Br2. Now you must put a light, okay, light, okay, or HV. Never put aqueous, will be wrong, okay, you minus marks. So this one is very common, right? Now this ring reaction, one more. This beside having free radical or substitution reaction, number two, it undergoes oxidation. This is very commonly asked here. You can see here. Okay? Here. Oxidation, which means that you can react with oxidizing agents such as these three fellas here. Okay? Hot, must be hot, hot. Hot stuff, hot. Okay? You can find books, there are three of them. Dichromate, potassium dichromate, acidified. K-amino4, acidified. Now sometimes they put K-amino4, okay, and with alkali can also use, you understand this why later, then followed by acid. Same, because if it's alkali, you get a salt. Because why? You get carboxylic acid. So the salt, you convert to the carboxylic acid, you put acid. So better to put H+. But marking scheme can see both of them, okay? Okay? Nitric acid also can be used. So, but this is the favorite. So K-amino4. Why? Because of alkenes. See now, in alkenes, K-amino4 is the favorite now. Okay. For alkenes, my dear students here, you good news are, this has no reaction with alkenes. Only a K-amino4 can be decolorized. Understand now? Okay. So that's why K-amino4 is chosen. Okay. So now here you can see here, right? With K-amino4, right? The K-amino4, hot K-amino4 acidified, you get your benzoic acid. Now this is a liquid at room temperature, RTP. But once it is oxidized hot, right? This one will dissolve in hot. But when it's cool, it's a solid. Remember this. It's a white solid. Benzoic acid. It's called benzoic acid. I told you when it's C6H5 one here, it's called phen. P-H-E-N-Y-L, okay? Like your CH3 is called what? It's called methyl. These are the names for your alkyl group. If C2H5 is called what? Ethyl, okay, and so forth. If it's C65, it's called phenol. and what? That's why your phenol, which you do next chapter, is phenol. Is phenol, PHENOL. So, all is an alcohol. So if there's 7 carbon, C6H5 and a C here, you call it Benz. Mercedes-Benz. Benz. So it's benzoic acid. Okay, that is used a lot in as antifungal, no? Fungal. It's used in your chili sauce, okay, to prevent fungus from growing. Right? It's used in your dusting powder on your armpit. You used to use that, but they found that this thing will go into your enter your bloodstream to the skin, so you stop using it. This will cause you not to have body odor. Okay, this fella here. Okay. Now, interestingly is, of course, if the 2 carbons here, like this is your ethyl, okay? Okay, it's a ethyl benzene, okay? Methylbenzene, ethyl benzene. Now, if you put O, this is quite commonly used, or if you balance it with 3O2 enough, okay? Because it's called nascent oxygen, means atomic oxygen, very powerful, and you can come from straight away from the sun. This will give up your oxygen as uncombined very fast. Okay, so in this case here, right, the oxidized now, or any carbon here, 2 carbon, 1 will knock off as carbon dioxide. It is 3 carbons. Okay, let's say 3 carbons here, CH2 and then CH3. These 2 will be knocked off, and you will 2 CO2 here, and only 1 carbon here will remain as your benzoic acid, which is of course C double bond O and OH like that. Okay, you can put either way. See? And of course, if there are 2 CH3 here, both of them will be formed. It's a dicarboxylic acid. Okay? The ring will not undergo any oxidation. Because why? The electrons here, the pi electrons are delocalized, stabilized. Remember that? The resonating, or the resonance structure, or the resonance energy. Okay? So they will not, unlike a normal double bond. Okay, normal double bond, KMNO4 will oxidize it, right? You get your diol, and if you break here, you cleavage here, you get your carbon dioxide and your acidic carboxylic acid or whatever. Okay, so remember, must be hot. Cold cannot react. Condition hot and acidified. Okay. Right? Now the side chain reaction, of course, is very simple. Now here I don't know how this stupid thing now. Okay, it should be here CH, it is CH3 here. No, it means it's jumped up here. Okay, right now for this reaction, of course, if you use chlorine and light, remember UV light. Okay, that means here just behave like a normal alkane. You get electrophilic, spherical substitution. Okay, right, and you can continue to halogenate it. You get CH and Cl2. Okay, and you can continue here. Okay, now in the ring reaction here, right, this is quite common. Ring reaction here, this one here, it will act like a normal ring. Of course, it's undergo what? Electrophilic. What? Substitution. Okay, already not very good there because I need to hurry up. Okay, now this is called the first wife. Bini number 1. Okay, this will, so whatever that enters here, you call it X positive, whatever here, I say positive, okay, can be Br positive, can be Cl positive. Remember that, okay, all these are electrophiles. Or maybe another NO2 positive, or maybe another CH3 positive. Don't care. All this, when you come here, this fella here will direct, or they call it orientate. Orientate, okay, whatever. Okay, right, will direct to enter which position. Now, these 2 positions here are the same, right? Because this is what? This is a symmetrical molecule now. Okay, now this is called the ortho position. Ortho, O-R-T-H-O. These 2 here are called the meta position. And I told you before, this one position is called the para. para sakura, okay, para position. Now, this fellow here, now if you look at your data booklet, I'm going to show you your data booklet here. You have what you call in number 9, in partners, number 1 here, or number 3, okay, number 9, they actually give you, see, this is called the orientating effects of aromatic substitution reaction of R. Now this here, or here, see the position, see, I want to put this over here. Now the position, I had to do this again. What? Okay, here we are. The position of the incoming group. This is called the incoming group. I put X as it, doesn't matter, okay? It means this is positive. It means this is a what? This is an electrophile. Okay? Now, it's determined, that means the position, that means 1, 2, 3, or 4. It means this is actually 2 lah, this is actually 3 now. Okay, they are same one. You know. It's determined by the nature of the group X here, that means this one here, the nature. Nature, what is the nature? The nature is, well, there are 2 nature only. 1, 2. One is electron donating group. You see after Y, okay, they don't put here. Group. The other one is electron withdrawing. Like high electronegativity. Electron. Well, this donating, this we are accepting, okay, or withdrawing, like the word. Withdrawing group. Okay, so 2, I show you afterwards, okay? All right, the question comes out here. Now, remember this was only introduced, I think, last year only, okay? This table here. Before that, they actually asked, it was not on the syllabus, but they asked, but they give you the information. Okay, now you can see that if the first wife here, okay, first wife, right? If it is electron donating group, like all this here, see that? Okay, all this here. Now actually X here. This part here is the X is electron donating. Okay? Electron donors. This part here, the X here is electron withdrawing group. Yeah, this pen. Okay, see now. So if it's electron, now these are all electron donors. I'll explain later why I cannot. Okay, right? They give it to you in exams. It means you don't have to remember, but it's good to know lah. All these are electron withdrawing groups, you know. Okay, all the electron withdrawing groups. So they will direct you to the third position. Now I show you the question first of how they come out. Right? I'll go back to here, and it is page 37. There are 2 questions here. Now see here, all right? So remember, now let's look at the question here a bit first. Okay, now this is your reagent. This is your benzoic acid. I want to nitrate the benzoic acid, okay? Nitration. So they use such words, okay? So CIE uses these words. All right? That means they use what? They use con H2SO4 or con HNO3. What else? Con H2SO4. What else? And temperature 55. Okay. So the NO2 positive here will enter the ring. So where will it go? Second, third, or fourth position. Now remember here they only want 1. Okay. It's called mono-substituted. Mono-substituted. Okay, that means only 1. Okay, kick out only 1 hydrogen. So from here to here, where is it going? Now, here, okay, the position of substitution during electrophilic substitution of Arenes is determined by the nature of the group already attached to it. That means that the first wife. And who's the first wife? COOH. Okay, COOH. Now they tell you last time that thing, this one was not given. This was not given. this table was not given in the data booklet. Okay, they here, which means they tell you. Okay, so they say what electron withdrawing groups. Okay, these two are your benzoic acid and your nitro. All right. Okay, these are your first wife. You can see here, right? NO2 and carboxyl. Okay. Here got more. These two are electron withdrawing, which means that the second wife will go to the third position, the third room to sleep. Okay. The husband can go to the third room to have sex with her. Okay. All right. Now here, so they tell you that, well, this electron withdrawing group here, right, will direct the second wife to go to this position. That's why I go here. So, okay. Now on the other hand, electron donating group, this one here. I'll tell you why they okay. This one here. Okay, that means they push electrons inside. They push electrons inside. This one here, they pull electrons out. Okay. So here they will decrease the electron density here. That means it will be less reactive. Less reactive than benzene, of course. This one is more reactive than benzene. Why? Because the electron density here is what? Is enriched. Has increased. Yeah. So bromination is faster. That means it can go to, there are two possibilities. You can see here. It can go to the 2 and the 4th position. That means there are 2. So you put either one, you also get marks. Of course, sometimes they even go to di-substituted and tri-substituted. But here they don't confuse you. Okay, you can have this one here. This is a di-substituted. And also you can have tri-substituted. That means it's the complete one. Okay. So here they didn't want to confuse it because this was not in the syllabus. So here they ask you use this information to suggest likely structure for organic product for each of these following. Okay, it's simple, isn't it? So for bromination, which means you're going to use your bromine, stash what? Fe, Br3, and heat. Okay, and of course you go where now. Remember this NO2 group is where? NO2 group is of course here. Right now, it's the first wife, isn't it? Right? It will direct it to what? The third position here. You know. So what you get? Very simple. It's a very simple one. Once you know the ice question NO2, right? So I get the Huion tablet, you can do everything here. Okay? Here. Right? Of course, sorry. I don't want to make so much mistakes. I say eraser. Okay. Okay, what? Do this again. Okay, BR here. Yeah? Okay? You only want 1. Of course, now here if you 2 furthers here. These 2 are direct confrontation. NH2 here, right, is what? We'll go to 2nd and 4th position now, okay? And then the carboxyl, say what? It go to the 3rd position, okay? So they are in conflict, but don't worry. So NH2 here is electron donating. It'll be these 2 positions, okay? Right? And this one here occupied already. This one here will be the same, same metal position. So undergo here or here, right? So chlorination will be Cl2 and what? Fe, Cl3 and heat. So of course you will get what? Okay, go back and do by yourself. Remember they only want 1 chlorine to go inside there. You put 2 chlorine, if you put 2 also doesn't matter. This will be here, either here or here, isn't it? So put a Cl here. Cannot. This is called orientating factors. Okay? Right? Now, I think, okay, one more question for you. Because there's a summary of question, okay, 56. Here again, you can see, right? In aromatic substitution of so forth, and blah, 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 right? Now here is where they will ask you to use a brains if you have any lah. Okay, remember here last time they don't give you this table, right? That means they will tell you where it is. In exams, if the thing coming out there is on the syllabus, they will tell you the theory. Right here, they tell you the theory. Remember the CH3 here, the first 5 here, they're already there. The methylbenzene to undergo the second substitution, which means here they want to substitute the hydrogen here for NO2, right? Of course, what will they use? They use corn what? Corn HNO3. This is all you must remember, no? You don't remember, you fail. H2SO4. And of course, 55. These are all facts. Too bad. You do A levels, you just must memorize. Unless you open book test and you don't memorize. Okay, right? So remember, they tell you this is what? 2 and 4, isn't it? But here they tell you is 4. Position 4. So they tell you here. So don't use 2. But nowadays you can use both 2 and 4 because it is in the data booklet. And this photo here, the first 5 here is a what? Is a position 3 there. Here. Same conditions. Go to here. Now, so now they ask you to apply this idea. Okay? Using this information as an aid, suggest the structure for C in the formation of the synthesis of 3-bromone. I want to make some here. Now notice, there are 2 reactions here. The CH3 has become a carboxylic acid. Why? Because the carbon here, see, carbon here. And the hydrogen here has been substituted with your bromine. So what do I do first? Shall I change this one first to here? Okay, how do you change this one to here? Theory. This is your KMnO4, isn't it? KMnO4, what? Acidified and heat, isn't it? Okay. How do I get the bromine to go to hydrogen here? Very simple also. How? Use Br to rating. Fe, Br3 or Al, Br3 or whatever. Okay. And heat. So which one comes first? Okay. Remember, they want to keep the position the same. Okay. Right. So if you want to put bromine first, right? This fellow here, the CH3 will direct bromine to where? To this position there. Right now, because 2 and 4 ma. So you won't get this position. Yes or not? So if you put Br2 and Fe Br3 and heat, you get what? You get this one here, CH3. And you can well here you can put here or at the bottom. You cannot get it on this side here, on the third position. So you won't get an answer. So what do you do? The best thing of course is to oxidize. So here, change it to your carboxylic acid first. Okay, first one is KMnO4, acidified and heat. What you get? COOH and your ring. Yes? Second part is what? You use a bromine, isn't it? Br2 and Fe Br3 and heat. Then you will go to the, see? They ask you for conditions and it's all here. No. Do you understand? So this is called orientating factors. Okay, now I'm going to go to one more idea before I go to some. I think we'll summary first. Okay. Now look at the page 50. Okay, 50. Some of these questions you have to know how to use them. Now you can try by yourself. I won't do it here because I don't want to waste time. Okay. See now here they give you this. Remember this was before it was in the syllabus. Before the data booklet has got the table there, right? So here they give you the whole workup here, the whole thing here, the whole thing here is theory. Okay, so then of course, remember electron releasing, okay, or they call it donating. So they use different words, okay? That means if it's donating, it means give electrons here, it give you the otro and the para, so it gives you only the para position. If it's electron withdrawing, right, it's the third position, okay? So they give you the groups here. So remember in exams, right, if ever they give you a new theory, they will give you something sort of syllabus, they give you the theory first, so don't worry. Okay, so now the whole thing now is in this. Now I want you to go back and try. All this you've done before. Remember Br2 and LCl3, yes or not? Yeah? Cannot. That means it's bromination, isn't it? So you can use LCl3 or AlBr3 or whatever. Okay? Then they go on to, now remember this one here, I told you, Chemisry alkali, you know, yes, and then acidified, okay? That means they're going to attack the side chains, yes, side chain here. Yeah? Now here is your nitration, yes, okay? Now the only thing new is this one here. I'll explain to you here. Okay? This one also I will later explain. Now this of course is a reducing agent. Especially reducing agent. Which will reduce your NO2 in the ring to NH2. Later you see, okay? This must be in the ring. Okay? You see afterwards. Okay? Right? So now this whole thing, try and do it yourself. Now one more question is in page 730. This is a very old question. So they don't really care. Yeah, it's not here. Okay? They don't really care where the position is. Don't worry. I just want you to hold it now. Here, now these two things. We're gonna look at this one here. And this one here. See? Both of them, remember this is CH3 here. This is CH3 here. This is CH3 here. So if they give you the skeleton, again, draw all the atoms up. Okay? Now this, of course, this one is for what? It's for the side chain reaction. Right? This is for what? For the ring reaction. So the point is, how many of this chlorine enters here? So you got to look at the end from the beginning, the end here. Okay? How many hydrogens are being lost from here, this one, and here and here? So it's very important to see the whole picture before you begin solving the problem. Now, leave it to you to solve this problem. I want to go down to the chlorine first, okay? Okay, now we have done this one already. So let's go back to the chlorobenzene. Okay, now in chlorobenzene, remember they ask you here in the syllabus. I've done this already now. I've done E already. Applied knowledge within the position. Okay, I've done this already. Right? I've done, now I'm going, this one here. We've done 3 already here. One here. Okay, effects of delocalization. Okay, and all they've done already. So now I want to do this too. Today we'll finish off all Arenes already. Fantastic, isn't it? I hope you guys are looking at this video to learn by yourself, because then we're doing flip learning. Otherwise, you die. This year, all your grades will depend on your A2. Okay, yeah. Okay. So now we talk about here. Interpret the difference in reactivity, which is faster, benzene and chlorobenzene. Predict halogenation. That means chlorine enter the side chain. The side chain or the ring. Okay, so we're going to look at all these things for chlorobenzene. The rest, all we have habits, right? You don't say I have not done my work. It's you who have done your work. Okay, now chlorine. Let's look at the first one first. Okay, the page 25 first. 25. See, I've done my work. 25. Okay, now look carefully here. Contrast the reactivity of chlorobenzene and chloralkane. But of course, you have to talk about this one here in terms of with benzene. I'm going to show you the structure here first. Okay. Now benzene is a flat molecule. I know, okay, and with the drop here, okay, and with the pi electron club on top here, bottom here, okay. Here's your hydrogen, 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 hydrogen. Okay, I'm going to put different colors just to make it more fantastic. Okay, hydrogen here, hydrogen here, hydrogen here, hydrogen here, hydrogen here. Now I'm going to draw here is your chlorine. All right, the bond here is chlorine. All right, Cl. Chlorobenzene, right? Now chlorine, remember, chlorine has got 7 electrons. 1, 2, 3, 4, 5, 6, 7. Okay, so if it bonds here, now I'm going to draw here so I don't want to waste the thing here. So if it bonds here, one here will be from your benzene, from your carbon here. The 1 electron here, not very good. Let me just rub it off first. Okay, let's do again. Okay, the carbon here is undergoing sp3 or sp2. So it's flat, isn't it? So there's 1 electron here. Now chlorine, I'm going to put red color, okay? Right, chlorine here, so 1 here. Oh, cross that, okay? Now this is your S, this is your p orbital. This is p orbital. So now they are okay, right? You can put here s orbital, whatever, I don't care. But let's say the remaining 2 here is also your p orbitals. Okay, p orbitals, right? Okay, some people think is sp. Now, what happens is that here, right? The chlorine here. Kill a mosquito. The chlorine here, the p orbital up here and down here, 2 electrons. So the p orbital is able to overlap. So overlap here with the pi electron club. So it goes inside here. That means it makes this bond stronger, no? So the carbon chlorine bond is stronger. It's shorter and stronger than a normal, than aliphatic, that here, than a normal alkyl halide. See now? So this one here. So this is weaker. This one here can react. Remember not? What goes in here is normally OH minus. Remember? This is your what? Nucleophilic substitution. Okay? Right? I better on. I don't know whether it's off or not, but the lightning. Is it still recording? I'm not sure. Let's say it's recording, okay? I'm not sure. Let's see. All right, now here, as I said, it will make this bond stronger, so the chlorobenzene cannot react with nucleophilic substitution. That's why you can see here, right? The chlorine atom bonded to benzene is not reactive, it's inert towards all this. See, all these here are what? Are nucleophiles. Right? Now in this case here, now this carbon here and this carbon here. For chlorobenzene, the carbon here, well, the OH minus here, if they were to attack here will attack this carbon and break this bond here. Right? But if now the OH minus here will attack, it will attack this carbon. Right? Because the C here and the Cl here is separated by this carbon here. So there is no overlap here. No overlap here. Right now. So this is a weaker bond. So this side here can undergo what? Can undergo a reaction. That means you can get alcohol from here. That means you can undergo nucleophilic what? Substitution. But here cannot. No reaction. You won't get a phenol from here. You won't get this compound. OH cannot. No reaction because the bond, the Cl bond is very strong. See? Now can you see from here all this, right? If the carbon separates this carbon from this Cl here, it can undergo any reaction. It's not come up all the time. Okay, I show after scale, right? Can get your cyanide group inside here, which is the nitriles. But if this one here, in ethanol and heat with your chlorobenzene, what happens? Nothing happens. No reaction because the Cl bond is very strong. Same thing with ammonia. Ammoniolysis, same thing here. You can see here, right? The chlorobenzene is unreactive because of the overlapping of the p orbitals, or what? The overlapping of here, okay, here, right? Overlapping of the p orbitals, the electrons of the p orbitals. Overlapping. Okay, with the what? With the pi electron cloud. Cloud of the benzene. Okay? Benzene ring of 5 line. Okay? So now that is the theory of this part here, which we will probably end. Okay? I'll show you some questions first. Right? Now this is what they want you to understand here. You see here? Right? Predict the here. Predict the halogenation, okay, side chain and aromatic, okay. And here, the difference of reactivity between benzene and chlorobenzene. Now I'm going to show you here. So the point is, will the chlorobenzene be more reactive than the benzene or not? Which means I know it's a bit distracting here. Never mind. I'll show you the thing here, page 13. I got 13, okay. Okay. Now see here, right? Electrophilic substitution is, which means that they ask you to compare here. I'm going to do it here, okay? I'm going to draw here. They say now, relative rates of aromatic electrophilic nitration of, okay? That means I got benzene here. And I got chlorobenzene here. I compare these two. I got nitration, concentrated HNO3, concentrated H2SO4, okay? And of course, I put 55 for both of them. This is a hydrogen here. So of course, you will get here NO2, the nitrobenzene. Here, you get your Cl. Now the point is here, you see, we see that chlorine, the thing overlaps with the pi electron cloud, overlaps in. But chlorine is also electron withdrawing agent. So if chlorine is a withdrawing agent, that means it will direct it to where? To number 3, isn't it? That's not right. And but if it's overlap, if overlap here is also electron donating. Right? It will also, suppose there are two things here. If it donates here, it will increase the rate. And it should what? It should direct it to 2 and 4, is it? Yes, not. So there seems to be a contradiction here. Now they found that first thing on rate, right? They found from experiments there, they found that the inductive effect is stronger. That means pulling away stronger. If you pull away stronger, that means you reduce what? The electron density here. That means the NO2 positive will be less reactive. They found it's less reactive now, see? Compared to benzene, less reactive. Right now, but now on position-wise, where will chlorine direct it? Okay, chlorine now. Chlorine still go on to 2 and 4. See? So one win, one lose. 2 and 4. Interesting, isn't it? Right? So chlorine, even though it's electron withdrawing, because of the overlapping effect, it will direct 2 and 4, but it's less reactive. Okay, because of the electron withdrawing effect. So you can see here, right? So you have to understand it's less reactive because of the electron withdrawing group. Okay, right? But the position-wise, it will go to 2 and 4 because it is electron donating in a sense. Okay, now let's look at the question. Okay, I'm going to be a bit longer here. I hope we are taping this. I don't know what happened. Blah, 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 blah. Okay, chlorine, chlorine, page 30, whoa, 13. Let's look at page, sorry, page 29. Okay. All right, we did the first one here. Now here, typical reaction. Methylbenzene can react with chlorine in 2 ways. See here, right? Why 2 ways? Because, I put the cursor here first, okay? Otherwise I cannot get the position. This is a side chain. And we have the nucleus or the ring. Okay. So the first one is going to the ring. It means that this is what? This is electrophilic. What? Electrophilic. What reaction is this? Substitution. Substitution. Okay, which means I require Cl2 with what? With Fe, Cl3 and heat. You must always remember the reagents and blah blah blah, otherwise you will die. Okay? Right? Remember CH3 will direct here. Now, if here to here chlorine, and I want to substitute on the CH3. Of course, I use Cl and UV light, UV light. Okay, right now to here is what reaction is this? Is free radical substitution. See now? Okay, simple, is it? Now this is just a chlorobenzene. Now the other one that we need to look at, of course, is okay, 37. Now this is where the hard stuff is. Okay, 37, 38. So 38 here. There's one more question here. Sorry, 29, better 29 first, okay. 29, I got the electrical storm. Never mind. Wait, 29 finished already. There's one, okay. Okay, 37. All right. Yes, 37 here. 37, 38, 30, okay, 38 here. Okay, now look, remember very carefully, this time we've gone through it before. Predict the products of the following reactions, draw their structures in the boxes provided. Note the molecular formula in the final. See, they tell you, always look at the question. They will give you hints on molecular formula. That means you need to know. From here to here. Okay, now count the number of carbons here. 6 here, 7, 8. It means it's C8. Count always. Use your brains, okay? Okay? 1 hydrogen, 2 hydrogen, 3 hydrogen, 4 hydrogens. Here no hydrogens here. 4 plus 6, how much? Huh? H10. Yes or not? Yes or not? Okay, now here, from here, right? All right, I've got 8 C8. That means the number of carbons remain the same. It means the structure should be like that. So you use it to guide you to answer the question. It means like that, and it's still going to be a carbon here, and it's still going to be a carbon here. See now? Okay? One extra, see the hydrogen remain the same. Then it's an OH here. That means it must be adding an OH minus not. Yes? That means there must be an OH here. Of course, the H here remain the same. So you use it to predict what kind of reaction it's going to be. Right? Now, what is it here? I put chlorine like here. That means this fella is going to undergo what? Free radical. What? Substitution. That means one of these hydrogens here will come out. That means I'm going to get, well, all right. Either one will do a CH2 and a Cl here. It's just be a CH3. That's not. Now remember, I told you, remember, this is OH minus. That means it can attack this chlorine. Okay, I'm going to draw it up nicely. Okay, Robert's on here. Why is it not doing that job? Very slow. Okay, now let's go back to this one here. Okay, now here, H here, and your Cl here. The O, 2 electrons here are going to attack this bond here. Why? Because it's delta negative, it's delta blood. Positive. It's of course part here. Kill 2 mosquitoes one shot, man. Fantastic. These little mosquitoes are killing me. Now, here will of course this is like an LQ halide, right? Okay. So of course this one will attack here. Remember that the C cell bond here is weak. If the Cl is to the ring, cannot. Remember that the chlorine to the ring cannot. So it will attack this carbon here. And of course give you this product. Okay? Plus of course the Cl minus coming out. They don't want this thing here. Right? They just want this one here. Now here, look at here. Here is going to have this reaction, which means now compare here to here. Same thing here. Here's C8H10. Here's what? C8H10. 8, sorry. No. Okay? Right? Okay, and here is a chlorine here, no? Guys, it's a chlorine here. Okay? That means it means here to here, see this one here, of course, is your electrophilic what? You must know, you don't know then, go and fail substitution. It means it's going to go into one of these sides, rings in. Now here in this old question here, they don't care which part, okay? One of the part, that means it's going, that means the Cl going to enter into one of them here and kick out the hydrogen here, right? Now here is going to nitrate. Again, that means it again undergo what? Again undergo a electrophilic substitution. It means twice, which means if the number of carbons remain the same, the ring here is CH3. Of course, I got one chlorine here, don't care where, okay? And of course, one NO2 here. That's not. Any position will do. Here, they don't care where the position is. Okay? Right? Okay? So in this case, here, now you count again whether correct or not. Here's one, number of hydrogens, right? One, here's, don't have 1, 2. 2 plus 6, 8 is it? Okay? Right? So this is correct. How many chlorine here? 1 chlorine here. How many nitrogen here? 1 N and 1 O2. See, same, correct. Do you understand? Okay? So this is like a summary question. You're going to do it again. Okay, now here. I'm going to finish already. Now here, again, you put KMNO4 and alkali. And then you have to then acid and heat. Which means It's going to react with your CH3 here. See now? Right? Oxidation here. So you get what? Get COOH here. The ring will still be, both of them will be can say oxidized. Okay? The side chain. Right? Now then you add these two. Now, this is where your form 5 or form 5 will come out, okay? Or your AS. Carboxylic acid with alcohol and corn acid and heat. What happens? Esterification is it. Both of them will undergo esterification, right? So remember, in esterification, if it's a carboxylic acid here, okay? Now I told you before, if you don't remember, go and revise, obviously you'll fail. Alright? Here will come up, okay, and form your ester xenon, okay? Will form, of course, what? This one here. And your O and your CH3 here. So you can see here, I want to draw it more on this side here. So you have to know your chemistry, otherwise this is a summary question you cannot. Okay, remember here, remember now this is your carboxylic, yeah? Draw here, and your O and your CH3. Here same. Carbon, O and what? O and CH3. Now count. How many carbons here? 10. 6 plus 2 plus 2. C10. How many hydrogens here? 1 hydrogen, 2, 3, 4. 4 plus 6, how much? 10. H10. How many oxygen here? 1, 2, 3, 4. Voila, correct. Now this is how we should tackle the whole thing. Okay? Now I finished the whole bit, the whole thing here, all right, of your Arenes already. Right? I finished everything already. See, interpret the reactivity, is it? Benzene, chlorobenzene, and the halogenation of side chain. So I finished the whole thing. There are 4 parts. Okay? So the next time I will do is on your phenol. And look at the syllabus carefully here, guys. Just a round up. I forgot. There is one thing I need to give you is all the faster questions. Wait, now look at the I say organic chemistry. Okay. Now we have finished all this already. Yeah, so this whole part of Arenes, 15.4. The whole thing here. Position, last one here. So the next time we do it, of course, these are all AS, right? All these are AS. Phenol. And ester here, acceleration here, the dark part. So we're going to do phenols and acyl group. The next one, which is part 5. Okay? So make sure you do your revision, make sure you're on top of everything. All right, remember, see the aim from the beginning. See your A star. Not E star, idiot. A star from the beginning, and then work for it. Nobody's going to give you free lunch, okay, I tell you? Okay? All right, so we're going to stop.